Okay, my friends, this is going to be a very interesting discussion. What is a metallic dragon? Everybody's heard of dragons, and there is a million of them. Every culture talked about them. Well, what is a metallic dragon? It's distinguished typically by the color and composition of their scales. Well, I am very deep into chemistry, and I fully understand metals and what their colors look like, and I think I can show you a metallic dragon. You know, I tried the nice route of being all courteous and please take it, and nobody cares a bit. So I'm going for the abrasive route, and I'm just challenging them. I challenge them to do their job as scientists. Now, what are we seeing here? I'm calling those transition metals, and I'll tell you exactly why I can say they are. And I'm saying this is biology, not just dead rocks that form from lava, which is exactly what you're going to hear from. They have no explanations for these things whatsoever. This is the transition metal area. These are the chemicals of blood, ferrous oxides. That's your what carries the oxygen around your body. All these other things they have what they call ligands. They attach little molecules to a metal core and drag it around. And these we're talking about metal dragons. All right, I just showed you what they're talking about, metallic dragons, and now I'm going to show you one. And these are the colors of metals that are in blood, and they are carried around in aqueous solutions. That means watery stuff that's in your body. They attach and detach from molecules using these plus charges, basically, to attract and drop off oxygen, vitamins, glucose, all of the things a body needs to survive. And these are in the blood. All of these different metals, and they are in the center of the periodic chart, transition molecules. And they transition, they transfer things all through your body. Very, very important. And in blood and these colors, and in dragons, they had those colors. All right, so I showed you that we were talking about aqueous transition metals in waters, which would be like that running down these different colors. That's kind of interesting colors. Well, let's see where that's coming from. Look at all those colors running off. Well, they're coming from dragon scales right there. Now, those dragon scales are on the tip of a giant dragon. Now look at these different colors. Look at the different colors there. Why are those different colors? Why are those different colors? Those different colors because they're different transition metals. And they bond in different ways. And I'll show you exactly the way they bond. I can see the actual bonding. I understand this, like I'm saying, if it's true, it's true. I understand this better than anybody right now that's alive. Fully understand exactly what's going on here. What is the difference here? Why is this like this, and this like this, and this like this, and this like... Those are different transition metal colors. And here's the reason they bond together like this in biology. Because, here, let me just show you something. This was a paper I did long, long ago showing about dipole molecular moments and how polar molecules have like a plus end and then negative ends down here. And then there's going to be centers of positive and negative charge. What that means is when they bond with another one of their own type, they're going to end up with having a bunch of stuff hanging off the edge of it that wants to attract more of this. So the blue will want to attract more of the blue. But at some point, another molecule will start to attach to the edge, and then it will grow like this. And in biology, it just happens automatically. It's programmed into the DNA to do that. But that's how these attach, and that's why you see these different separations. I'm not guessing at any of this. You see that? It just doesn't happen accidentally, and it didn't just happen there. It happens on all of them. You see that? This is biology, my friend. This is not just dirt and rocks and mountains. That is running off biology because this thing is dead and decaying, and it is enormous. All the way across North Africa. From the actual tail tip down is here. It's got a fluted tail. But that I showed you is the good scaly dragons with all the, dragon scales with all the blood running off. And all of this stuff, all the way back to his head. This is his head way here. So you go all the way from here. And I've been through everything, all the digestive system, the whole 9 yards. And this is his face right there. All right, there's a red dragon eye, flaming dragon eye. All right, now, all the way down his throat, runs all the way down here. This is the runoff of the red blood. That's the red and the black blood. All right, so that's, you know, and they would call this hematite, and this is magnetite, or red and black, but this is running out of this dragon's neck. Now, this is his throat all the way down here, you see that? And the same dragon scales are up here. Same dragon scales. You see them? That's not, that's just, why would these different colors be like that? It's exactly what they say in the ancient texts about Tiamat and these dragons that had metallic scales. I can't tell you. It's just what they say, and that's what there it is. If you can't tell that that's what it is, I don't know. I don't know how I can help you. Not only that, this dragon was spitting out some extremely noxious transition metal elements, and these are the things that do the damage. Transition, well, they can do damage and they can do good, but they are extremely reactive, let's put it that. And as you can see, that is the most reactive, nastiest stuff you're ever going to see. Look back here, coming out of his throat. This is right out of his throat. All right, so here's his head. The throat runs down here. He's spitting stuff out right here. And that's the stuff. Now, we're talking about transition metals and the colors and all the nasty stuff that comes out with it, and that's it. Now, that is extremely, totally, devastatingly reactive to the things it hits, as you can see. All right, those aren't just accidental little patches of brown and red and blue, and those are actually invasions. Now, what happens as it went down here from his face? It hit this gigantic fish's fin. All right, you see the fish? I'm only showing you what's here. Now, if you can dispute it, dispute it. But I can show you biology in undeniable biology. Right now, I've shown you the dragon, and I have gone through the digestive system, and it has a cloaca. And people are living in the poop of the cloaca right here, which is the best spot where it has all of the flow of stuff coming out of it right here. This is where they're all living because it's very fertile. It's, you know, poop grows stuff good. And that's where they're living, right in that spot. And that is the cloaca where it drains. It's an avian creature, so that's the poop spot right there. And they're living there because it's good poop. Now, they're hitting this, he's hitting this fish, and either he just expelled this accidentally, I think he attacked the fish, you make that decision. It came down from his throat, from the head of the dragon, straight down, you can see it. Pow! Well, what did it do when it went pow? Well, here's what it did when it went pow, that's it right there. This is biological blood vessels. All right, it's eaten through the outer stuff, you know, the flesh and so forth, down in the scales, down into the actual blood vessels. This would have been all blood vessels feeding the tissue that's under here. These are the feeders, and these are the little blood vessels. That is biology. That is the way life works when it's exposed as it is. Now, and you can see from down here, it only came down to here. And that's when it stopped cutting into his vital flesh. And these are scales, but you can't see through these to see that same anatomy underneath, like is exposed as the acids, and they must be some kind of acids, ate through those scales above. This is what the vital flesh looks like when it's not eaten through. And this is exactly what it looks like when you eat it through. And that was done by this invasion of chemistry by a dragon against a fish. Now, if there's a biologist, an anatomist, a chemist, a geologist, any ist that you can bring to bear, I will gladly discuss my findings. And I have much more than this. This is just the tip of the tip of the tip of the dragon iceberg. All right? And this was at one time a giant water body. And all of this stuff, as you can see, if you take just a second, you can see all of that stuff flowed out right there. That's exactly the way mud flows. You know, what you need to do is get a kid to look at this stuff. They could tell you in 5 minutes, oh, yeah, we may put mud out there just like that. And when it runs out, it collects. And then when it collects in a pile, it goes off to the side like that, the Cape Verde Islands. That was made by the collapse of what I think was the Atlantis, which is right here. Plato puts it right there. It's on Herodotus' map. And it sure has all the signs of something that had a bunch of entries coming up to the ports from outside. Anyway, and you can see it collapsed. It was right outside the Straits. Plato said it was outside the Straits, but everybody said it was, oh, it's the Straits of Hercules. No, it's these straits. And that gave them total control of entry to the Sahara Ocean. And then when it collapsed, which Plato said it collapsed, 9,000 BC, something like that, all of this stuff drained across and out. Because before it was held back. There was a ridge here, apparently, that kept everything back. And when Atlantis collapsed, it all... And Plato says they will never talk about mud again. They will never speak of mud again. So much ran out. Which obviously did. Now they call this an alluvial plain, which means it's just flat as a pancake, because this was all mud ran out here. But the explanation from academia is there was an offshore collapse that caused this. But again, get an 8-year-old or so and ask him what caused this. What do you think happened here? He would say water drained across there. I would. And, you know, I'm just as smart as an 8-year-old. Okay, my friends, now is where we get real serious. This is not just a joke. This is the list of dragons in mythology and folklore. These are just Asian dragons. Arabian, Armenian, Chinese, Babylonian, Indian, Indonesian, Japanese dragons, Khmer, Korean, Persian, Philippine dragons. Everybody had dragons. Then there's European dragons. This was not just one guy talking about a dragon. They all had their own ruler, which was a dragon. Even North American dragons. And I have found them in North America, no question whatsoever. I found Quetzalcoatl, which is this guy here. I found all of them. Well, and I haven't found all of them. I mean, look how many there is. South American dragons. African dragons, oceanic dragons. Just let it run through your head for a second. You think this was all just a game to these people back then? And then they put them on maps where they really are located? This is our true ancient history. Now, you can run from it, you can hide from it, and go to Yale and Harvard and all of the top schools that'll tell you, don't listen, just Roger's an idiot. Or you can go to reality. And if this was all our ancient past, can it affect your eternity? I think it can. And I'm just going to tell you right out flat now, I've been doing this for a very long time, digging as deep as you can possibly dig, going to both sides of the track, and I was always a non-believer of any of this nonsense. And then I realized it's true. What did it mean then? To me now, it means find Jesus Christ. He's the only one that I have found that ever spoke about peace. I mean, they talk about some of these dragons being very, you know, good rulers and so forth, but from what I have found, I am going to look for Christ. That's the only one. As far as my eternity goes, if there is an eternity, that's the guy I'd want to spend it with. You do what you think is right. All right, I'm just going to leave you with this. I believe this map goes back to maybe 1375. I don't know where I got it from. Somebody, I downloaded from somewhere or whatever. But it was as detailed as you can get. It shows the Red Sea. This is like Italy and all of this stuff. And it's very, very detailed. And there's a lot of writing on this, which I don't know what the heck it means. But I can tell you what this means right here. This is the dragon. That's the dragon scales. and it runs all across North Africa, and there's the dragon's throat cut. You see right there, why would they do that? Well, because his throat was cut. I showed that his throat was cut. Right in that one specific spot. I think I've already shown this, but I'm going to do it again, because that is where the throat is cut, right there. So I think we got a lot of looking to do about the actual truth of what our history is. And if, you know, I am out for truth. I don't care about being in the comfort zone anymore. You know, you could say ignorance is bliss, and that is true. That is absolutely true. If you could stay just ignorant of this, it won't play on your mind. All right, because it's going to play on your mind. If you looked at this and you could just slough it off and go about your business, well, then ignorance is bliss for you. Have a nice day. But if you have a mind and you think about things, well, this is going to play on your mind. Okay, I just want to make something clear. I have been harsh on academia and all of the educators because they are literally stuck in a trap. They cannot speak. They have what they call peer review, which means no one will be allowed to go against their group. Groups are like that. They focus in on a way of doing things, and if you go against that, you're done. Because we can accelerate light. Okay, if you can't see that's accelerating, they say, "Oh, that's not accelerating. We're peer reviewed, so you can't tell us that because we know what's right." I showed them. This is the particle that swishes right out of that pulse red laser. It is a particle, and it is accelerating as far as I can determine, and that is the particle. And they actually show this. Fermilab shows this exact same particle, and it's, "Oh, no, you can't. You're not peer reviewed, so." You know, you're just totally wrong. Well, these are the Higgs fields. They show those. I show the same exact identical particles they show. So here's what we're stuck in. You see this here? This is not my doodle. This is from Fermilab, I believe. They want to see a muon. They want to see electron shower. They start out with the muon neutrino, electron neutrino stuck together. The white and black ball showed you a moment ago. They explode into showers, and just the muon stays black ball as it was. And here's the showers. Identical. Not allowed because I'm not peer reviewed. I don't think that's right. And I think that, I don't know how to handle it because nobody will respond whatsoever anymore because I have too much evidence for them to respond. So however we handle this, I don't know. But at least if you're watching, you'll be somewhat educated, and then hopefully you'll speak up. Either that, or you'll just be one of the minions that says, "Oh yeah, whatever you tell me, I'll say. Just tell me, boss. Just tell me. I'll do whatever you tell me." Well, I had a hard time with that. I'll tell you that right now, and I hope you will too. You know, everybody's screaming about how we have to have energy in it, and we do, and we are destroying the earth because of combustion. And this, my friends, is, I believe, 200 times more energy than we started when I showed you that original laser. Same thing they're showing here. Muons are supposed to create enormous amounts of energy. Now, these are the electron showers. How we harvest this, I'm not sure. But there's new transition metal thin films that will harvest this kind of energy in copious quantities. If we can do that, I think we get free energy. But I, again, have tried to contact every place, literally every lab, Fermilab and all of them, CERN. I went to the University of Geneva for particle physics. I showed them this, and they said, "Oh, that's nice," and nobody would discuss it with me. So nobody wants to talk about something that upends their theory, and that's what it is. This is like a competition. It's not like they really want to get to the end of the thing. They just want to compete and say, "No, stay away from me. You got too much. You're going to destroy me." And that's what they're worried about, is being destroyed. I don't want to destroy anybody. I want to save the world, basically. Because right now, this case is closing very soon. Even the pole is shifting. Every time we burn anything, the envelope of gases expands, as it does the scrub against the non-vacuum of space. That's totally nonsense, too. These are the things that are out in space. All the light particles coming to us from the sun, from everywhere. Dust, everything is out there. Now they're finding sodium and all kinds of different molecules out there everywhere. So we're scrubbing through that. And as we do, it heats our ionosphere up to 2,700 degrees. They don't understand that either. And they never will understand anything until they talk to me about dipole electron flood theory, which is this right here, where everything is a dipole. Electrons are made out of dipoles. That's why they split, a black and a white. Don't understand this. A photon is two electrons back to back. And they have the muon and electron neutrino, but that makes up what I call an electron. The only way we split them was because of the Venturi we designed to be so tightly tuned that would only let the squishy white particle through. And that white particle is squishy, as I will now show you. I've shown it 1,000,000 times, but let's go to 1,000,001. Well, probably more than that by now. Whoops, there it is. That's the black and white particle. Only the white ones can get through. The black ones are fixed. And Fermilab says it. They understand that. They've made that same statement. They're a fixed particle. The black one is a fixed particle. The white one can squish through, and it does. Where's Fermilab's? I got something here that shows what Fermilab had to say. Somewhere, but I'll probably never be able to find it. I got so much stuff. But they show it as a point particle and a fixed particle. So that's just the way life is. All right, there it is right there. This is the Fermilab point particle. This is the one that's the squishy one, the white one. I agree with that. And this is the fixed one. And they say it. The Fermilab point particle is this, and the fixed particle is that. This was from an article Don Lincoln put out years ago. So they know these particles exist. They just they are digging through debris of hitting head-on billions of particles at a time. They see these particles. They know they exist, but they just don't know how they got to be where they are and where they came from. And these do not exist. It's only one big size, just like that. We see them in the green, we see them in the red, we see them in the blue. There is no difference. I don't think that the size of the black one. So it's not like several black sizes. There's one big fixed black particle. Case is closed. And everything that is made up of atomic vapor, which is these particles. All right? They start out just one set, which is an electron, well, basically an electron, and it has a dark and a white side. And there's another electron back to back, just like two little bar magnets. And you add 1,839 of these together, and you end up with a proton. And you just keep adding more and more and more of these tiny particles, and you get bigger and bigger and bigger molecules and atoms. That's how it works. So we need to start right from scratch again. And not being allowed to speak makes it very difficult to scratch that surface. Now, either you step up and help me, or we just continue on doing what you're doing, and hopefully you'll be able to live that life. I couldn't do it. All right, I'm just going to leave you with this. When you start talking to people, they say, oh, this guy's an a-hole, forget him. Well, you know what an a-hole means, an asshole. And that's just an insult to say, just forget about him. Well, you forget about me because when we talk about behaviors, the asshole was not necessarily being antagonistic towards people, but they just didn't really care about what others were thinking or how they were perceived by others. When you have proof and evidence and all of the science that I have behind the statements I make, I couldn't care less what they say. I want them to say something, and they won't say something because they know they are defeated.